Good afternoon everyone, welcome to your chemistry class. So as we discussed yesterday, today we will be discussing about the chemical equilibrium chapter. It's a little bit lengthier chapter, same as like thermodynamics, because chemical equilibrium comprises both chemical as well as ionic equilibrium. I will be trying to finish both the things at a time. Yeah, so what I want is everyone has to be ready with the pen and paper so that you can write all the important points and notes about this chapter. Okay, so if you guys are ready and set up your mind for everything, we can start the class. Is it? Give me some reactions so that I can get a positive sign from your side. Everything is fine? Is my audio, video, everything is fine, students? Okay, what happened? Am I audible to you? Or yeah, students, let me know whether my audio, video, is it still have problem? For everyone, is it for everyone or just for few people? Okay, network, voice is breaking. Okay, like what about now? Is it, isn't anything clear? Just wait, just give me a few seconds. Okay, so what about now? Yeah, thank you for your response. Yes, sorry for the network problem. Yes, so students, as we discussed today, we will be discussing about the chemical equilibrium and ionic equilibrium part. So all of you ready for the class? We will be starting and we will be mentioning all the important points of this chapter. Yes, so if everything is fine and clear, we can start the class. Is it? Audio, video, everything is fine? Sure, right? Can we start the class? Yes, thank you. Yes, so we'll be going to the first part, discussing about what is the definition. What is the definition we can give for a equilibrium? Okay, it is that state of a system in which all the measurable properties like temperature, pressure, color, mole, everything become constant. That is the condition for a reaction to be at equilibrium. Okay, now that is the normal definition of equilibrium, but we want the definition according to thermodynamics also. According to thermodynamics, what is equilibrium? According to thermodynamics, equilibrium is that state of a system in which free energy become minimum. That is Gibbs free energy delta G should be less, and what about entropy? Entropy should be maximum. That is what the thermodynamic condition for a system to be at equilibrium. That's a point. This point also you have noted down. This is the normal definition. Okay, now we can move into what are the different characteristics of chemical equilibrium. Yeah, the first characteristics I want everyone to take a notice. Okay, it is possible only in closed system. It is possible only in closed system. Why it is possible only in closed system? Because consider a reactant is converting into product. If the product is gaseous product, a gaseous product, what is going to happen? If the product is a gaseous product, what is going to happen? The product will be escaping out from the container. If it is an open one, the gas will be escaping out from the container, and when it escapes out from the container, what you can see is the reaction will be moving only in a one single direction. If products are removed, product is removed immediately from the container, the reaction will be moves only in one direction. And equilibrium is possible only if there is both backward as well as forward reaction takes place at the same time. Okay, that is first of the property. Now the second properties of the system remains constant. That already we have discussed. That is, if the temperature, pressure, color, concentration, if any of these properties remains constant, then we can say the system has attained equilibrium. Okay, there is a point that it need to be only constant. It no need to be equal. That is a point. It no need to be equal. If it is equal also, that is an equilibrium condition, but that is not a mandatory condition. If it is a constant, that is enough for a reaction to be at equilibrium. Okay, and next one is it is dynamic in nature. How we can say that equilibrium is dynamic in nature? Consider that a reactant is converting into product. At the time of equilibrium, let's imagine that reactant is 5 mole. Reactant is 5 mole and product is 6 mole. Just imagine that reactant is 5 mole and product is 6 mole. At the time of equilibrium, what is happening? The concentration of reactant and product become constant. How it become constant? By moving the system. It is dynamic in nature. By moving it, How it become constant? That is what I am going to explain. That is when one molecule of reactant is converted to product. When one molecule of reactant converted to product, another molecule of or another mole of product will be converted to reactant. In which number of moles or concentration of reactant and product will be always 5 and 6. Okay, but they will be always in moving. Always they will be moving. That is, if one mole reactant converted to product, at the same speed, at the same rate, one mole of product will be converted to reactant. That is why I am saying it is dynamic in nature. It is always in moving. Okay, yes. Now the fourth point, chemical equilibrium can be achieved from the both sides. Yeah, that's a very clear idea. That is H2 plus I2 gives 2Hi. This is a forward reaction and this is in equilibrium. This is in equilibrium. At the same time, if I am taking the backward reaction, 2Hi gives H2 plus I2. This is also equilibrium. This in the backward direction also we can achieve the equilibrium. That is what I have mentioned here. Chemical equilibrium can be achieved from both the sides. Okay, so just concluding the points, chemical equilibrium is possible only in closed system because if there is a gaseous product, it will be escaping and reaction will move only in single direction. Okay, that's the first point. Second one is properties remains constant, like concentration, color, density. These need to be only constant and it's not necessary to be equal also. Okay, the third one is dynamic in nature. Why it is dynamic? Because at the time of equilibria, the number of moles of reactant converting to product will be equal to number of moles of product converting into reactant, in which concentration will remain same, but they will be always in a moving. They will be always moving, and that movement or the speed or the rate, it will be equal. Okay, yeah. The last one is reaction can be achieved in both direction. Okay, that's all about the small characteristics of chemical equilibrium. Okay, now few more points I want to add. Yes. Okay, what is happening to the rate? What is happening to the rate at the time of equilibria? Consider that a reactant is converting into product, in which reactant converting to product is a forward reaction and reactant converting to product is the backward direction. Okay, at the time of equilibria, what is happening? This is the point. At the time of equilibria, the rate of forward reaction will be equal to the rate of backward direction. Rate of forward reaction is equal to rate of backward direction. Okay, and there is no change in concentration of reactant and product. No change in concentration of reactant product, that will remain constant. That is what just we have discussed. That is what the chemical equilibrium, and it is dynamic in nature. Already we have discussed this one. Okay, hope it is clear. That is when I am saying that if one mole of reactant is converting product, at the same time one mole of product will be converted to reactant, and this conversion speed, this is the rate of forward reaction and this is the rate of backward reaction. Okay, and this rate is equal. Rate of forward is equal to rate of backward. This rate is equal at the time of equilibria. Rate need to be equal, but concentration no need to be equal. That's the point. Concentration or pressure or the measurable properties no need to be equal, but rate need to be equal. That's the point. Yes. Hope it is clear. If it is clear, I can move to the next part. Done? Yes. Okay. Okay. Now this is the graphical representation. Yes. Now when the reactant is converting into product at time t equal to 0, what we can say? At time t equal to 0, the amount of reactant will be maximum. Let's imagine that reactant is having number of moles A or concentration A. Amount of reactant will be maximum. So how I can draw the concentration of reactant versus time? The amount of reactant will be maximum at time t equal to 0. Now as time progresses, what is happening? Products start increasing, products start forming. So and the reactant will be start decreasing. Reactant will start decreases, and at a particular time it will be remains constant. The amount or the concentration remains constant. Now what is happening to the product at that time? At the time the product concentration will start slowly increases. At the time t equal to 0, the concentration of product is 0. Now as the time progresses, the concentration will increases, and it will be reaching up to a it will be reaching at a particular time in which it is remaining constant. Okay, this is how the graphical representation of reactant and product over time. Okay, yes. Now I can combine these two graphs. Yeah, here is a combining form of this graph. Look at here. That is concentration versus time. Here you can see the concentration of reactant decreases and the concentration of product increases, and at a particular time you can see both become constant. At that time we can say equilibrium time. At that time I can say it is equilibrium. Okay, done everyone? Is it clear? Now I want to say few more graph also. I want to give few more graph also. This is concentration, can be product or reactant. Time. Is it at equilibrium? Is this one represents equilibrium condition? That's my question. Is this graph is representing equilibrium condition? Yes or no? This graph represents equilibrium condition, right? Okay, what about this graph? Is it going to represent equilibrium condition? I want the answer from you. Yes, yes, very good, Surabhi. Yes, it will be remains equilibrium, because you can see after a particular time, the concentration is remaining constant. So we can represent it is equilibrium condition. Okay, now one more graph I want to say. Okay, now in this condition we can see at the end of the reaction, the concentration of reactant is greater than concentration of product. Okay, now what about this one? Is it representing equilibrium condition? Students, is it representing equilibrium condition? Yes or no? Yes, is it going to represent equilibrium condition? Yes or no? Can you let me know? Is it representing equilibrium or not? Can just unmute. Yes or no, Sangeeta? Sangeeta, you are saying something? Yes, it is correct. It is correct. Here also you can see after a particular point of time, concentration of reactant and concentration of product both become equal. And also is constant. So in this one we can see the concentration of product is equal to concentration of reactant in this time of equilibrium. Okay, and the third type of equilibrium, here you can see the concentration of reactant is lesser than concentration of product at the time of equilibrium. So these are the three different graphs I can say it is applicable to a equilibrium condition. Okay, is it clear to everyone? Is it clear to everyone? One more graph I will tell you. One more graph I will be giving you. You have to tell me whether it is equilibrium or not. Okay. Shall I give you one more graph? I am going to give one more graph in which rate versus time. Is it equilibrium? Is it equilibrium? Is it equilibrium or not? Is it equilibrium or not? Yes or no?
Yes.
Yes or no?
Yes, sir.
No. Here is a mistake that you will be doing. Here it is rate versus time. What is the condition? What is the condition for rate and time to be at equilibrium? At the time of equilibrium. At the time of equilibrium. Okay, this is rate and this is time. At time t equal to 0, when time t equal to 0, we know that concentration of reactant is maximum. Concentration of reactant is maximum. If concentration of reactant is maximum, rate of forward reaction will be maximum, right? Rate of forward reaction will be maximum. If the rate of forward reaction is maximum, what is going to happen? Rate of forward reaction is maximum means as time progresses, the rate of forward reaction will decreases and rate of backward reaction will increases, right? This is the rate of backward reaction, and at a particular time it will be remains constant. At a particular time it will remains constant, and this is what the equilibrium condition according to rate. That is, the rate of forward reaction become equal to rate of backward reaction. This is the equilibrium condition. Okay, equilibrium. Got it, everyone? Got it? Yes or no? Rate of forward and backward should be equal. It not need to be like, condition is like it should be equal only. It's not like it has to be constant. Okay, so don't get confused between all these things. We will be, yeah, just give me a minute. Okay, shall I move? Are you clear with this one? Graphical representation of concentration versus rate. Yes. Now we will be moving into the law of chemical equilibrium and equilibrium constant. Law of chemical equilibrium and equilibrium constant. Yes. Law of chemical equilibrium. How we can derive the law of chemical equilibrium? Listen very carefully here. Okay. Yeah. Law of chemical equilibrium, it is derived from the law of mass action. According to law of mass action, consider a reaction in which A plus B gives C plus DD. Consider this reaction. Okay, and according to law of mass action, rate of forward reaction is equal to rate constant into concentration of the reactant raised to the power of their stoichiometric coefficient, that is A, and B. And according to rate law or law of mass action, rate of backward reaction is equal to rate constant into concentration of the reactant raised to the power of their stoichiometric coefficient. Okay, this is according to the rate law. Now according to the equilibrium, Kf by Kb is equal to K equilibrium. And on taking the ratio of both, I am taking the ratio of both, what I will be getting? I will be getting concentration of K equilibrium will be equal to concentration of product divided by concentration of reactant. That is what law of chemical equilibrium. According to law of, what is according to law of chemical equilibrium? According to law of chemical equilibrium, equilibrium constant is equal to concentration of the product of the concentration of the product raised to the power of the stoichiometric coefficient divided by concentration of the reactant, product of the concentration of the reactant raised to the power of their stoichiometric coefficient. That is what according to law of chemical equilibrium. This is a very simple and easiest formula in which I hope everyone know. Okay, is it clear? Is it clear to everyone? Students, is it clear? Yes or no? I need a response from your side. Okay, thank you. Okay, now I am moving to the next part. Okay, before going to the next part, just note down how we can calculate the equilibrium constant unit. Equilibrium constant, you can see it is the concentration of product by concentration of reactant, and on doing the ratio of it, what we can see mole per liter vol to the power delta Ng, or change in number of moles of product by change in number of moles of reactant, that is C plus D minus A plus B. This is how we can easily find out the unit of it. Okay, so already everything is there. I don't want to waste time over here. Can I move? Yes. I'll give you a few questions so that you can do it. Yes, thank you. Okay, here is a question. Write the expression for equilibrium constant for the following reaction. For the following reaction, write down the expression for the equilibrium constant. Yes. Yeah, try it. Students, try it, all of you. How we can find out? How we can find out it? Okay, here you can see I am going to take the first reaction. Okay, 2 NH3 gives N2 gas plus 3 H2 gas. Okay, now these are gaseous molecule. For gaseous molecule, what is the active mass? Here one more thing is you have to note down active mass. For aqueous solution, the active masses can be either represented in concentration, only, and for gaseous substance, the active mass can be represented in terms of partial pressure and also in terms of concentration. And for solid and liquid, the active mass is equal to 1. Okay, these are the active masses. Okay, now you can find out the equilibrium constant expression here. Here you can see as these NH3 is in gaseous, all are gaseous, so the equilibrium constant, active mass is that mass which is taking part in the reaction. That is if I am taking for aqueous solution. For aqueous solution, how we are representing the mass or amount of aqueous solution? We are representing the aqueous solution amount or mass by concentration, right? 2 molar, 1 molar, 5 molar, right? That is what the active mass representing. But for gaseous substance, how we are representing the amount of substance? In terms of partial pressure, right? In terms of partial pressure, that is the active, that is what we call it as active mass. Is it clear? Is it clear? Or do you want more explanation? Yes, thank you. Yes. Okay, now this equilibrium constant I can express, as it is gaseous substance, I can express it in two ways. That is, I can express it in terms of concentration as well as partial pressure. Okay, how we can represent it? First of all, concentration of product divided by concentration of reactant. Which are the product? N2. So concentration of N2 raised to the power of the stoichiometric coefficient, that is just 1 only, into H2 raised to the power of the stoichiometric coefficient 3, divided by NH3 raised to the power of the stoichiometric coefficient, that is 2. This is the equilibrium constant in terms of concentration. Now in terms of pressure, if I am taking the active mass as pressure, how we can write the equilibrium expression? For N2 it is represented by partial pressure of N2 whole to the power 1 into partial pressure of H2 whole to the power 3 divided by partial pressure of NH3 whole to the power 2. This is how I can express the equilibrium constant for a gaseous substance. Majorly we will be expressing gaseous substance in terms of pressure, but we can also express it in terms of concentration also. Is it clear, everyone? Is it clear? It's a very simple thing only, there is no much complication in this one, very easy thing. Now all of you find out for CaCO3. For CaCO3, how we can find out how we can write the equilibrium constant expression. CaCO3, which is in solid state, converted into CaO, that is also in solid state, then converted to CO2 gas. How we can convert? K equilibrium will be equal to active mass of the product, Here, what is active mass of CaO? Tell me the active mass of CaO, calcium oxide. What is active mass of CaO?
1.
It is 1, very good. So I will be representing it as 1. 1 into, then CO2, active mass of CO2. What is active mass of CO2?
CO2.
How we will be expressing that? What is active mass of CO2? CO2 is a gas. So I will be writing the active mass of CO2 as partial pressure. Partial pressure of CO2. I can also express in terms of concentration also. Then divided by CaCO3, which is in solid state. What it is? What is active mass? 1 only, yes, that's only. So for CaCO3, K equilibrium will be equal to partial pressure of CO2. That's only. Everything is clear. Got it? Don't make any mistake in this one. Yes. If it is clear, shall I move? Shall I move with the next part? Yes. Okay, this is what the answer for it, K equilibrium, and for CaCO3, CO2. Okay, now just everyone understand this one, no need to write or anything. There are two types of equilibrium we can say, that is homogeneous equilibrium and heterogeneous equilibrium. Homogeneous and heterogeneous. Homogeneous equilibrium, what does it mean? If all the reactant and product are in same phase. Here you can see N2 which is in gaseous state, H2 gaseous state, NH3 gaseous state. We can say this is a homogeneous equilibrium because all the reactant and product are in same phase. Here also aqueous. It is a homogeneous equilibrium. Now what is heterogeneous equilibrium? If the reactant and product are in different phases. Here you can see H2O which is in liquid state is converting into gas. It is a heterogeneous. CaOH twice which is in solid state converting into reacting with the water which is in liquid state converting into Ca2 plus which is in aqueous state and OH minus which is in aqueous state. So these are heterogeneous equilibria, just for your understanding only, because question can ask among the following which is representing a homogeneous equilibria or which is representing heterogeneous equilibria. Okay, I think I can move to the next. Can I move to the next? You got it, everyone? Yes. Okay, now the type of equilibrium constant. Which are the type of equilibrium constant? Look at here. Two type of equilibrium constant I want to introduce to you, that is Kc, molar concentration, in terms of molar concentration, and Kp in terms of partial pressure. These are the two type of equilibrium constant. That is, if I got a reaction, AA plus BB gives CC plus DD. If I am expressing this equilibrium constant in terms of concentration, then I will be using the equilibrium constant Kc. But at the same time, if I am expressing it in terms of partial pressure, I will be using the equilibrium constant Kp. That's the only thing. That is the only thing. Kc and Kp. Okay. Now how it is connected, how Kp and Kc is connected, this is the important equation. How Kp and Kc is connected, it is connected by Kp is equal to Kc into RT to the power delta Ng, RT to the power delta Ng, important equation. You can see a lot of PYQs or previous year questions from this part. Kp is equal to Kc into RT to the power delta Ng. Now what is this delta Ng? What is this delta Ng? I think this delta Ng I have discussed it in thermodynamics. Thermodynamics I have discussed. What it is? Yes, number of moles of gaseous product minus number of moles of gaseous reactant. That is what the delta Ng value. Okay. Is it clear? That is, if I am giving N1A, N2B gives N3C plus N4D, and if all are gaseous, what is the delta Ng value? Delta Ng is equal to N3 plus N4 minus N1 plus N2. Remember that we need to only add the gaseous product and gaseous reactant. If any of these one is a solid one, example I can give. Okay, N1A which is solid plus N2B which is gaseous gives N3C gaseous plus N4D which is gaseous. What is the delta Ng value for this one? What is the delta Ng value for this one, this particular reaction? Tell me. What it is? N3 plus N4 minus
N1
minus N2 only. That is the point here, because here N1A is in solid state. We no need to consider the number of moles of that reactant which is in solid state. For delta Ng, delta Ng is, what is the equation for delta Ng? Number of moles of gaseous product minus number of moles of gaseous reactant. If any of the reactant or product is not in gaseous form, then that no need to consider in the delta Ng equation. That's the point. That will be the mistake that you will be doing. Don't do this mistake in the exam. Is it clear, everyone? Shall I move? Yes. Okay. Yes. Okay. Now here is a question for you. Write the expression. Okay, just give me a minute. All of you do this question. Write the expression showing the relation between Kc and Kp in the following reaction. Yes. Anybody got the answer? Anybody got the answer? Expression showing the relation between Kc and Kp in the following. So first of all, we can just write the Kp and Kc. What is the Kc expression? Kc is concentration of, Kp is equal to Kc into RT whole to the power delta Ng. This is the relation between Kc and Kp, right? Okay. Now what is the only thing we need to find out here? We need to find out only the delta Ng value here. What is the delta Ng? Number of moles of gaseous product. This is gas, so the number of mole is 2 minus gas 3 plus 1 gas. So 2 minus 4, it is equal to minus 2. Minus 2 is coming as a delta Ng value. If delta Ng is minus 2, Kp is equal to Kc into RT whole to the power minus 2. This is the Kp Kc relation. Is it clear to everyone? Is it clear? And if the question asks like what is Kc? Kc will be equal to Kp divided by RT to the power minus 2, or Kp into RT to the power 2. Okay. If you got Kp, you can find out Kc. If you got Kc, you can find out Kp. Okay. Is it clear to you, everyone? Is it clear? Shall I move? Everyone done it? Yes. Look at here. Yeah. Okay, now we will be moving into the properties of equilibrium constant. This is the part in which we can see a lot of questions. In the last mock test also you can see a questions from this part. Okay, how we can solve these questions? Look at here. Go through the properties of equilibrium constant. Yes, the first property. Equilibrium constant is a reaction specific. It is a reaction specific, that is, it is a constant for a particular reaction, and it will be changing only if the temperature is changing. It will be changing only if the temperature is changing. That is, for a given reaction, equilibrium constant depends only on temperature, And what is the theory that is connecting the relation between equilibrium constant and temperature? Anybody have any idea what is the theory? We discussed it in different chapters. In which chapter? Which chapter we have discussed it? Chemical kinetics we have discussed. What is that? What is that theory called? Arrhenius equation. Arrhenius equation is telling about the relation between equilibrium constant and the temperature. And according to Arrhenius equation, K, equilibrium constant, K is equal to A e to the power minus EA by RT. Yes. According to this, what is the relation between K? K is, or if K increases, or if the temperature increases, equilibrium constant K will be also increasing according to this reaction. Okay. Shall I move? Okay. Now coming to the third one. How we can find out equilibrium constant of the new reaction, Okay. A plus B gives C plus D. Consider a reaction A plus B gives C plus D, and the equilibrium constant K for this reaction is concentration of C into concentration of D divided by A into B. Okay, now what I am going to do is, if I am reversing the reaction, that is C plus D gives A plus B. If I am reversing the reaction, what will be the equilibrium constant of the new reaction? If I am reversing the reaction, the new equilibrium constant will be the reciprocal of the old one. If I am reversing the new reaction, if I am reversing a reaction, the equilibrium constant of the new reaction will be the reciprocal of the old one. Suppose if I am telling you A gives D, the equilibrium constant K1 is equal to 2. What about the equilibrium constant for D to A? That is K2. What it is? For A to D it is 2. For D to A, what is the value of equilibrium constant? Tell me guys. 1 by 2. That's only very simple. 1 by 2. That's the first point you should note down. On reversing, it will coming as the reciprocal. Yes, 1 by 2. Shall I move to the next property? Okay. Now the next point is if I am multiplying it by a number n. That is, consider that I am taking a reaction in which I am multiplying it by a number n. That is Na plus Nb gives Nc plus Nd. The new equilibrium constant will be equal to the old equilibrium constant raised to the power of the number that we have multiplied. Consider that A gives D, and the equilibrium constant for this particular reaction is K1 is equal to 2. And what I will be doing, I will be multiplying this reaction, multiplying into 2. What it will be? 2A gives 2D. And what will be the equilibrium constant of the new one? A to D will be giving 2, and 2A gives 2D. What will be the equilibrium constant of the new one? Yeah, whatever the number that I multiplied, 2 square, whatever the number that I have multiplied, that will be coming as the power for the new equilibrium constant. That's the point. Done? That is, K dash will be equal to K to the power n, where n is a number that we have multiplied. Is it clear, students? Shall I move? Yes. Now properties of equilibrium constant. What are the properties of equilibrium constant? Yeah, the same thing only. Yeah, consider that I am taking two reactions. A gives C and B gives D. And K1 for this one is this one, and K2 for the second reaction is concentration of D divided by B. Now what I am going to do is I am going to add these two reactions. When I am adding these two reactions, the new equilibrium constant will be coming as a product of the old to product of the added reaction. Okay, product of the equilibrium constant of the added reaction. Okay, I can give an example. Consider that A to C, the equilibrium constant K1 is equal to 2, and B to D, the new equilibrium constant K2 is equal to 3. Now I am adding these two reactions, that is A plus B gives C plus D. After adding, what will be the equilibrium constant of the new one? K3 will be equal to what? What will be the equilibrium constant of the new one? K3. It will be the, when I am adding two reaction, the new equilibrium constant, yeah, will be the product of the added reaction, that is K1 into K2, which will be equal to 6. That's only the point here. Is it clear? I can move, right? Okay. So that's all about the property. Now this is a question for you. All of you try this question and get me the answer. Equilibrium constant for a reaction A gives C and B gives D were found to be 16, 50. 16 and 50. Then find the value of K equilibrium for the reaction C plus 2B gives A plus 2D. Here our two reactions are A gives C and the equilibrium constant K1 will be 16 and B gives D, K2 is equal to 50. What we have to find out? We have to find out the equilibrium, K equilibrium for the reaction C plus 2B gives A plus 2D. This is what we have to find out. So what you have to do is rearrange these two equations, first equation, two equation, in such a way that we should get this reaction. So look at the reaction that we need to find out. According to this reaction, C and B should be in the left hand side, but here you can see second equation B is in the left hand side, first equation C is not in the left hand side, it is in the right hand side. Screen is blur. Okay, is it for everyone? Is my screen is blur to everyone or Prathamesh? Okay, Sangeeta. Okay. For few I think it is clear and few, is it clear now? Okay, yeah, thank you. Yes. Okay. Now according to this reaction you can see C is in the left hand side, but here in the first one C is not in the left hand side, it is in the right hand side. So what I have to do is reverse equation 1. If I am reversing equation 1, it will become C to A. Okay, and the new equilibrium constant K equilibrium will be what? 1 by K1. If I am reversing, the new equilibrium constant will be coming as a reciprocal of that reverse reaction. Now what about the second one? You can see next B is there. B is having a stoichiometric coefficient 2 and D also having a stoichiometric coefficient 2. So what I have to do for the second reaction? Second reaction I have to multiply by 2. On multiplying, what is going to happen to the new equilibrium constant? 2. Okay, let's suppose this is K1 dash. This is K1 dash. On multiplying, I will be getting 2. B gives 2D and the new equilibrium constant K2 dash, it will be equal to 1 by K2 dash, it will be equal to 1 by, sorry, not 1 by, I have multiplied by 2, right? So the new equilibrium constant will be coming as a power, K2 to the power 2. So I got the two equation, 1 and 2. Now how I should get the final equation? If I add these two equations, first one and second one, I will be getting the final equation, that is add first one and second one. First one dash and second one dash. On adding this, what I will be getting? I will be getting the final equation, C plus 2B gives A plus 2D, and the new equilibrium constant for the last one, which will be, when I am adding these two reactions, I have to multiply these two. So 1 by K1 dash into 1 by K1 dash into K2 to the power 2, which is equal to 1 by 16 into 50 to the power 2. This is what the new equilibrium constant. Is it clear to everyone? It's a simple one only. Whatever you are doing to the individual step, the same thing you should do to the equilibrium constant also, and finally for adding you have to multiply the equilibrium constants. Is it clear to everyone? Is the question is clear? Yes. Any doubt or anybody want to repeat anything? Okay. I think it's not a big question, it's a simple question only. This type of question we solved in the mock test paper discussion also. Yes. Moving to the next part. Yeah, the answer is coming as 156.25. Okay, now the application of equilibrium constant. One of the important application of equilibrium constant is predicting the direction of reaction. For predicting the direction of reaction, what I want is, I am going to introduce one more term, that is reaction quotient. What is reaction quotient? Reaction quotient is the concentration of product divided by concentration of reactant at any time other than equilibrium. Q is reaction quotient which is defined at any time other than equilibrium. Okay, now based on the Q value and K value, we can find out whether the reaction will be goes in the forward direction or backward direction. How we can find out that? Okay, look at here. That is, if Q value is lesser than K value, always the system want to be equal to the K value. So if the Q value is lesser, what the system will try to do is, system will try to increases the Q value. How Q value can be increased? By increasing the concentration of product. How the concentration of product can be increased? Concentration of product can be increased if the reaction moves in forward. Concentration of product can be increased. So if Q value is lesser than K value, we can say the reaction will be moves in forward direction. That is, if Q value is lower, this is equilibrium constant K value. This is Q value. If the Q value is lower, Q value will try to increase its value and will try to reach up to the equilibrium constant. Okay, and this process of increasing the Q value will lead to the forward direction. Okay. Now if Q value is greater than K value, what will be the direction of reaction? Let me know in the chat box. Backward direction, that's only backward direction. That is, if Q value is greater, Q value want to reduce us, or Q value want to decrease its value. How it can decrease its value? By moving the product to reactant, or by decreasing the concentration of product. Concentration of product can be decreased only if it is moving in a backward direction. Got it, everyone? Shall I move? And if Q value is equal to K, means reaction is at equilibrium. Yes, good. So this is all about the application. Very important one, these terms. They will be giving some Q value and they will be asking what is the K value. Okay. Shall I move? Yes. Okay, this is what we have just discussed. For Q is less than K, forward direction. Q is equal to K, then it is equilibrium. Q is greater than K, it is backward direction. Okay. Now equilibrium constant Kc for a reaction. Okay, I am giving this for you only for a homework question. I will tell you how to do this question. Okay. Equilibrium constant Kc for the reaction. Here the Kc value is given, equilibrium constant value is given, and also the concentration or the composition of the reaction mixture is also given. That is for N2 3 mole, H2 2 mole, and NH3 5 mole, 0.5 mole. The question is the reaction is at equilibrium? reaction is at equilibrium, and if not, which direction does the reaction tends to proceed to reach equilibrium? That is what the question. How we can solve this one? Just now only we discussed about it. First of all, find out the Q value. Find out the Q value for this one, because Q value, see, it is mentioned that at a particular time, and this is not a equilibrium time, at any time. It has been observed the composition of reaction mixture is 3, 2 and 0.5. So using that composition, find out the Q value. How we can find out? Concentration of NH3 to the power 2 divided by N2 to the power 1 and H2 to the power 3, and the composition already given, or the this is mole per liter, right, which means it is a concentration. It is already given in the question. NH3 is 0.5 volt to the power 2 divided by N2. What is the value of N2? 3 to the power 1, and H2, what is H2? H2 is 2 to the power 3. On solving this, you will be getting a Q value. And if this value is equal to, you will be getting a value x. Okay, let's imagine that you will be getting a value x. If the value of x is equal to 0.061, then the reaction is at equilibrium. Then the reaction mixture is at equilibrium. If the value of x is lesser than 0.061, then it will be moving in forward direction. If the value of x is greater than 0.061, it is moving in backward direction. That's the point in this question. Is it clear? You can do it. You can find out the value of x by yourself. Just to do the calculation part. Can I move, students? Yes. Are you clear with this one? No response? Are you guys there? Yes. Next is the last and important part of this chapter, Le-Chatelier principle. What is Le-Chatelier principle? It's all about disturbing equilibrium. Now I am going to disturb the equilibrium. When I am disturbing anything at equilibrium, what the system will try to do is, system will try to readjust itself to nullify the extra effect and to become equilibrium. I am repeating once again. If a system which is at equilibrium and I am disturbing the equilibrium, I can disturb the equilibrium by doing these things, by changing the concentration, or by changing the pressure, or by changing the volume, changing the temperature, addition of inert gas. On doing any of these things, I can disturb the equilibrium. If I am disturbing the equilibrium, what the system will try to do is, system will try to readjust itself in such a way that to nullify the extra thing that I have done to change the equilibrium. And what is the readjustment? The readjustment is either forward or backward. System will move either in forward direction or in backward direction. That is what the readjustment. Got it? Now we can move into the each and every thing. First of all, if I am changing the concentration, this is the thing. It's a very easy thing only. Reactant to product. If I am changing the concentration, if I am adding reaction, reactant will be having tendency to convert to product. Reactant will be having tendency to convert to product, which means it is forward direction. If I am removing the reactant, what the system will try to do is, system will try to increase the amount of reactant by moving backward direction. That is backward direction. If I am adding the product, what is going to happen? If I am adding the product, what is going to happen? System want to decrease the product. How the system will try to decrease the product? By moving in the backward direction. At the same time, if I am removing the product, how the system will try to readjust it? By moving in the forward direction. Okay, that's a simple thing, all of you know, right? Concentration of reactant is, this is reactant and this is product. If I am increasing the concentration of reactant, equilibrium is disturbed. I want to decrease the concentration of reactant. For that, system will move in the forward direction. Okay, suppose if I am increasing the concentration of product, it should be equal always. Concentration of product, system want to reduce the concentration of product. How system will reduce the concentration of product? It will move in the backward direction. That's only if wherever it is higher, that will reduce itself by moving either forward or backward. Yeah, I think there is no much explanation required for this one. Yes, moving. Second one is about the effect of second one is about the effect of pressure. Okay, effect of pressure and volume. Look at here. Okay, this only affect reaction involving gases where the number of moles of gas changes. Okay, for pressure, very easy thing you have to note down is for a reaction, for a gaseous reaction like N2, okay, or like A which is gas plus B which is gas converting into C which is gas, D which is gas. Okay, the condition is that effect of pressure will be only if delta Ng value is not equal to 0. If the delta Ng value is not equal to 0, then only there will be effect of pressure. That's the first point you should note out. Delta Ng value is not equal to 0, then only there will be effect of pressure. Okay, when it is not equal to 0, two ways we can change the equilibrium. Either we will be increasing the pressure. If I increases the pressure, the volume will be decreasing, right? When the volume decreases, system will try to increase the volume, or system will try to decrease the pressure. How the system will try to decrease the pressure? By shifting the direction of reaction to a fewer number of molecules to reduce the pressure. By shifting the direction to a fewer number of molecules to reduce the pressure. Look at here. Yeah, N2 plus 3H2 gives 2NH3. N2 plus 3H2 gives 2NH3. Here you can see if I increases the pressure. If I increase the pressure, to which direction the reaction will proceed? Forward or backward? If I increase the pressure, to which direction it will move? Forward or backward?
Forward.
Yeah, it will be moving in forward. What I mentioned, if I increase the pressure, the system will move in that direction where there is lesser number of mole. That's the thing. Okay. Now if I decreases the pressure, what is going to happen? System will try to increase the pressure. How the system will try to increase the pressure? By moving the reaction to that direction where there is more number of moles. This is the 2 point you should note down. And only applicable if it for gaseous moles of reactant and product. Only applicable if it is for gaseous moles of reactant and product. Okay. Clear? Is it clear to everyone? Shall I give a simple question which is related to this? If it is clear, I can give. Consider that, okay, 2A solid plus B gas gives C gas plus D gas. On increasing pressure, which will be the direction? Which will be the direction of reaction? Forward or backward? Forward or backward? Which will be the direction on increasing pressure? Forward or backward? What I mentioned on increasing the pressure, reaction will move in that direction where there is lesser number of mole, right? Lesser number of mole. Among these, which side have lesser number of mole? Forward or reactant or product? Product. Are you sure? Lesser number of moles is in reactant side or product side? Reactant side. Why?
Reactant.
Yeah, only we have to consider the gaseous product and gaseous reactant. We won't be considering the number of moles of solid reactant or solid product. So according to this, 1 mole of reactant is converting into 2 mole of product. According to this reaction, 1 mole of product will be converting into 2 mole of gaseous. 1 mole of gaseous reactant is converting into 2 mole of gaseous product. So on increasing pressure, system will move into that direction where there is lesser number of moles. So backward direction. Now on decreasing the pressure, system will move in the forward direction. Okay, this is the point. Is it clear, everyone? Shall I move? Pressure is over. The point that you should note down for pressure is it will be applicable, or there will be shift in equilibrium only if the number of moles of gaseous product is, only if delta Ng value is not equal to 0. That is the first point. Okay, and second point is, on increasing the pressure, the reaction will move in that direction where there is lesser number of gaseous mole. Now third one is, on if I am decreasing the pressure, reaction will move in that direction where there is more number of mole. That's the 3 points you should note down for pressure. Is it clear? And this one should be the more conscious part. You should, that is solid. If it is solid, completely ignore it. Shall I move to the next one, that is temperature? Yes, you guys are tired? After 1 hour you started feeling tired? I can see the people are leaving. Okay. I think all of you are tired. Okay, we have no other option, students. Crash course, you have to sit, because now how many days are remaining? Only 15 days are remaining. How much effort you have to put, that much will be telling you how much mark you can get it. Okay, so little bit stress yourself, little bit put extra effort, then only you can. Only 15 days, no. After 15 days, after the NEET exam, you can enjoy or you can do whatever you want. But this is a time in which is very crucial, in which you have to put your maximum effort. So don't give up. You will be feeling something which is feeling stressed out, feeling anxious and all. It's quite normal. Every student will be feeling the same only. You should come out from it. Just put pressure on these 15 days. Then only you can able to produce, or you will be able to get what you are actually dreamed for these 2 years. Okay, so just set up your mind for everything. Just 15 days only remaining. Remember that one. Okay, yes. Moving to the next one, that is the temperature. Effect of temperature change. Okay. Effect of temperature change. Temperature is all about whether the reaction is exothermic reaction or whether the reaction is endothermic reaction. It's very simple only. Reactant converting into product plus heat. And this is what? Exothermic reaction. So for an exothermic reaction, what you can see is, if he increases the temperature, the product part is increasing, right? The product part is increasing if I am increasing the temperature, because heat is producing in the product part. So this will be increasing. If this increases, what the system will try to do is, decrease this part by moving backward direction. So for exothermic, on increasing temperature, it is backward, and for decreasing temperature, this is forward. And for endothermic reaction, that is reactant plus heat gives product. This is what endothermic reaction. That is, in the endothermic reaction is moving forward by absorbing heat. That is, in the reactant part you can see heat. Okay. Now in this, if I am increasing temperature, what is going to happen? Forward or backward? If I increase the temperature, this part will increases, right? That the reactant part will increases. If the reactant part increases, it will try to decrease by moving forward. Okay. So in increasing temperature, it will be forward, and for decreased temperature, it is backward. That is the part you should note down here. Okay, this is the only thing you should note down for the temperature. Is it clear, everyone? Is it clear? Shall I move? Everything I have mentioned in the PPT, I will be sharing it to you. Okay. Now this is the equation that you should note down. Why I am giving this? I have seen a NEET question, PYQ, from this part. That is, if you are given with 2 different temperature, an equilibrium condition you are given with two different temperature. In that case, okay, in that case you will be getting two equilibrium constant. K1 is the equilibrium constant at temperature T1 and K2 is the equilibrium constant at temperature T2. In this case, how we can find out the value of K1, K2 or enthalpy, whatever it is? This is the equation that you are note down. In terms of ln K2 by K1 is equal to delta H by R into 1 by T1 minus 1 by T2. Or in terms of log it will be K2 by K1 is equal to delta H by 2.303 R into T2 minus T1 by T2. Note down this equation. This equation may be not in your NCERT, but yeah, PYQ has been asked from this part. So note it down, everyone. Yes. Can I move, students? If you are done with it.
It's not Arrhenius equation.
Sorry?
Is this application of Arrhenius equation?
This is not the application of Arrhenius equation, but you can see this is having a similarity with the Arrhenius equation. And Arrhenius equation is all about, there will be EA, activation energy is coming, right? Activation energy is coming in the Arrhenius equation, but here you can see there is no activation energy, that part. Okay, this is a relation that is connecting enthalpy, equilibrium constant and temperature. Enthalpy, equilibrium constant and the temperature. Okay. Arrhenius equation we will be discussing very detailed in chemical kinetic chapter. Okay. Yes. Shall I move? Okay. If you got done, note down, then we can move. Done, right? Yes. Now the last part, that is effect of addition of inert gas. Okay. What is according to the inert gas? If I am adding inert gas, whenever the volume is constant, no need to think about anything because there won't be any shift. There won't be any shift in the reaction. Why? Because if I am adding inert gas at constant volume, it will increase the total pressure. It will be increasing the total pressure, but individual pressure or the partial pressure of reactant and product is not going to change. Overall, the pressure will be increasing. Okay, if I am adding inert gas at constant volume, what is happening is, if the amount of reactant increases, the pressure of reactant increases, at the same time pressure of product also will be increases. So overall it will be in the equilibrium only. Okay, that is overall pressure will increase only. That's why there is no shift. But when it's at constant pressure, you should note down the shift. What is the point you should note down? At constant pressure on adding inert gas, the total volume will increases and the system will be acting in such a way that to reduce the increased volume by decreasing the pressure. How it can be? The last point only you should note down. On adding inert gas, system will shift it to that direction with more number of moles of gas. System will improve or system will readjust itself in which direction, where there is more number of moles. That's the point you should note down. Is it done? Students, is it done? Shall I move? Addition of inert gas. Yes. I think I can move to the next part if it is done. For pressure cases, on increasing the amount of pressure, reaction will move in that direction where there is lesser number of mole. For adding inert gas, reaction will move in that direction where there is more number of mole. That difference you should be knowing. Is it? Shall I move? Can I move? Are you done with? Just note the last point, that's only. And the point is, at volume, constant volume, there is no shift. Only shift will be when there is constant pressure. Yes. Now one more point, that is about addition of catalyst. Shall I move, or do you want time to write anything over here? Students, I can move, right? Everyone? Okay. Now the last point, effect of catalyst. What the catalyst is doing? Catalyst is not doing anything to the equilibrium. Catalyst is not going to do anything to the equilibrium. That is, okay, this is energy and this is time, consider an exothermic reaction. What will be happening if I am adding a catalyst? If I am adding a catalyst, the reaction will find an alternate path. Normally the reactant will be converting into product. By crossing this energy barrier. This is what we call it as activation energy, by crossing this energy barrier. And what the catalyst will be doing is, after adding catalyst, what the catalyst will be doing is, it will be decreasing the activation energy. Catalyst will be decreasing the activation energy of the reaction. Okay, and provides an alternate path for the reactant to convert to product, which means reactant can convert to product in very short time. That is what the work of catalyst. What the catalyst will be doing, it will be producing an alternative reaction pathway with a lower activation energy, and will help to increase the help to reach the equilibrium in a faster rate. Okay, since both rate increases by same factor, concentration of reactant and product remains unchanged. Okay, so this is all about, there is no shift in equilibrium position, Kc will remain constant. Done everyone? Now that chapter is over. This is all about the chemical equilibrium chapter. We will be doing few PYQs, and after that we can go through few important topics of ionic equilibrium. Okay students, I want to say something. Ionic equilibrium, that is not actually coming in the part of our crash course, but I want to give you little bit idea about ionic equilibrium. Idea means some easy questions will be there in the ionic equilibrium. That everything I have added in the slide, and the details also I have added in the slide. If I am not able to complete ionic equilibrium, you just go through the slide and you just understand by yourself. Okay, and if any doubt you can reach out to me, I will be teaching you. Okay, now my question to you is, should I do the PYQ of chemical equilibrium or should I start ionic equilibrium? That's my question. What's your opinion? Half an hour we have, and only few selected topics only I have taken for the ionic equilibrium, which is very much important. What I should do, should I go for the PYQ or should I go for the ionic equilibrium part? Which one? Ionic equilibrium. Okay, Sangeet is saying ionic equilibrium. What about others? Same opinion?
Ionic equilibrium.
Okay, then I can go with the ionic equilibrium part. Okay, anyhow the PYQ questions are very easy only, not like everything is completely easy. Now you got the concept, you can solve it by yourself. Everything I have added in the slide, and the solution also I have added in the slide. You can refer it by yourself. Okay, now ionic equilibrium. Ionic equilibrium, first point, only 4 topics only I have taken. The first one is about the theories of acid. Question can ask, among the following which one will be obeying a particular theory? According to Arrhenius theory, acid will be giving H plus and base is giving OH minus, according to Arrhenius theory. Now according to Bronsted-Lowry theory, what is acid and base? Acids are proton donor, that is, if I am donating a proton, then they are acid. Same as like Arrhenius also. Arrhenius is also saying that acid is proton donor. Lowry-Bronsted is also saying that acid is proton donor. What is the difference? According to Lowry-Bronsted, base are proton acceptor, not bases which is giving OH minus. That's the difference we can see. Okay. Yeah, according to Lowry-Bronsted, acid are proton donor and base are proton acceptor. Okay. Now according to Lewis theory, is all about electron pair accepting and electron pair donating. According to Lewis theory, acid are electron pair acceptors and base are electron pair donors. That is a difference. Okay, just it's an easy thing only, but you may be losing the mark because of not knowing what is Arrhenius theory, what is Lowry-Bronsted, and what is Lewis theory. That will be the problem that is going to happen. Okay. Now one more thing is that conjugate acid base pairs. What is conjugate acid base pair? I am taking NH3. NH3 is adding on water. What is going to happen? NH3 is a base, right? NH3 is a base. NH3 will be taking proton from the water and it will be converted to NH4 plus. And this is base, and after accepting the proton, the base will become conjugate acid and water will become OH minus. So here it is acting as base and water will be acting as acid. After removing proton from the water, water will become conjugate base, and this is what we can call it as conjugate acid base pairs. Conjugate acid base pair. Got it? And what is the difference between conjugate acid base pairs? Here NH3, here it is NH4. Difference is 1 proton, and here it is H2O, here it is OH minus. What is the difference? 1 proton. That is what it is mentioned. Conjugate acid base pairs differs only by 1 proton. Differs only by 1 proton. Is it clear? 3 theories. Arrhenius theory is acid is proton donor, base is OH minus ion donor. Bronsted-Lowry theory, acid is proton donor and base is proton acceptor. Lewis theory, acid is electron pair acceptor and base is electron pair donor. This is the point only you should note down. And about conjugate acid base pairs. Done? Shall I move? And I am going in a very fast because I want to finish this. Is my speed is fine? Are you all able to understand the things? Is it, students? Yes, thank you. Okay, next is about dissociation of water. Another important point in which particularly NEET exam you can see this type of question. Dissociation of water. H2O. H2O will be dissociating into H plus plus OH minus. H2O will be dissociating into H plus plus OH minus. Now according to this equilibrium reaction, Ka will be equal to concentration of H plus into concentration of OH minus ion divided by concentration of H2O. Now concentration of H2O is a constant, right? If I am taking it to here, Ki into concentration of H2O, which is equal to concentration of H plus into OH minus. And this is a constant, equilibrium constant is a constant, and the concentration of water is also a constant. A constant into a constant is another constant which is called as Kw, which is called as ionic product of water, which is equal to the product of concentration of H plus into concentration of OH minus, ionic product of water, no doubt. Okay, now the problem is at 298 Kelvin. At 298 Kelvin, at 25 degrees Celsius, at 25 degrees Celsius, what is happening? Concentration of H plus is equal to concentration of OH minus ion, which will be equal to 10 to the power minus 7. At 25 degrees Celsius, concentration of H plus ion will be equal to concentration of OH minus ion, which will be equal to 10 to the power minus 7. So at 25 degrees Celsius, I can say Kw is equal to 10 to the power minus 40. That's the point. 10 to the power minus 14. Okay, this is for your understanding. At 25 degrees Celsius, concentration of H plus ion will be equal to concentration of OH minus ion and will be equal to 10 to the power minus 7. Okay, now if I take log, on taking log, what I will be getting? I will be getting that pKw will be equal to P. Okay, I am going to the final equation. On taking the log and multiplying it, what I will be getting? pH will be pH plus pOH will be equal to 40. pH plus pOH will be equal to pKw, which will be equal to 40. This is the point you should note down. That's the only thing I want everyone to take a note of it. At 25 degrees Celsius, concentration of H plus ion will be equal to concentration of OH minus ion. Clear, everyone? Is it clear to everyone? Yes. Now at the last, very important, there are 2 points. Effect of temperature. On increasing temperature, what is happening to the Kw and what is happening to the pH? This will be the confusing part. Okay, that is on increasing temperature. Slide you can refer it later. That's for your purpose only. Listen to here what I am writing. On increasing temperature, we know that H2O will dissociate, right? H2O dissociate more, which means more H plus or more OH minus ion will be forming. H plus ion concentration or OH minus ion concentration will increases. If H plus ion concentration or OH minus ion concentration increases, what is happening to the Kw? Kw also will increases. Kw also will be increasing. That is what, as temperature increases, equilibrium will shift forward and Kw will increases. Got it? Yes. Now what about the pH? What about pH? pH is equal to minus log H plus ion concentration. pH is equal to minus log H plus ion concentration. On increasing temperature, on increasing temperature, concentration of H plus ion will increases. If concentration of H plus ion increases, pH will decreases. That is a relation between pH and temperature. pH and temperature. That is what mentioned here. On increasing the effect on pH, since Kw increases, concentration of H plus ion increases and pH will decreases. Okay, but you will be thinking that at the same time OH minus also will be increasing, right? OH minus ion also will be increasing. If OH minus ion also increases at the same time, overall the reaction will be neutral, right? Overall the reaction will be neutral and the pH should be 7, right? pH should be 7, right? Then how the pH is decreasing here? Because pH is defined for the amount of H plus ion. On increasing the temperature, concentration of H plus ion will increases and the pH will decreases. Okay, but the thing is that overall the solution will be neutral. Overall the solution will be neutral, but the pH will decreases. That's what the concept here. Got it? Why the solution is neutral? Because how much amount of H plus ion is increasing, that much amount of OH minus is also increasing, in which overall the solution will be neutral. But pH is defined for the amount of H plus. According to the pH, amount of H plus ion is increasing, which means pH will be decreasing. That's what the difference here. Okay, don't get confused here. This is the complete idea about dissociation of water. Everything is mentioned here. Why have added these two things, effect of temperature? Because PYQ it has come. That's why. Is it clear, everyone? Take a screenshot of whatever I am writing, because there is a problem with my PPT in which I can't convert my annotations into the PDF format. That's the thing. Okay, take a screenshot and make a note of it. Shall I move? Everyone done? Yes. Now we will be particularly discussing about pH. Everyone? What about others? Have you got the idea about dissociation of water? Yes. Okay. Now pH calculation. pH calculation already we have discussed. How we can calculate the pH. pH is equal to minus log H plus ion. Okay. Now for strong acid and for weak acid. For strong acid and weak acid, how we can calculate the pH? Example, pH of 10 to the power minus 3 molar HCl. pH of 10 to the power minus 3 molar HCl. What is the pH of it? Can anyone let me know what is the pH of it? What is the pH of it? For strong electrolyte like HCl, it will be completely dissociating into H plus and Cl minus, right? For strong electrolyte like HCl, it will be completely converting into H plus and Cl minus. Yes or no? Yes or no? Yes. So if the concentration at time t equal to 0, it is 10 to the power minus 3, then at time t equilibrium or at the end of the reaction, the concentration of H plus will be 10 to the power minus 3 and Cl is 10 to the power minus 3. So which means what I got the concentration of H plus. So concentration of H plus is equal to 10 to the power minus 3. So the pH will be equal to minus log 10 to the power minus 3, which is equal to 3. Easiest way to calculate the pH for strong electrolyte. Yes, very good, Sangeeta. Now I can give you one more question. After that I will go for the weak acid. Shall I move to the next? People are starting leaving. Okay. Now one more question I want to. Yeah, what is it? 10 to the power minus 7 molar HCl. What is the pH? What is going to be the pH? Tell me, guys, what is going to be the pH? It is an important one.
7.
it's 7, you will be thinking that pH will be 7, but that is wrong. If pH is 7 means what? The solution is neutral, right? How an HCl be a neutral? That won't make any sense, right? In this case, what we have to do is, in this case we have to consider the concentration of H plus ion that comes from the water, okay, because the solution is very much diluted, that is 10 to the power minus 7 molar, it's very diluted, which means we have to consider the H plus ion from the water. Okay, and this question will be at 25 degrees Celsius. We know that at 25 degrees Celsius, concentration of H plus will be equal to 10 to the power minus 7, right? Okay, this is the concentration of H plus from water, and concentration of H plus from HCl, what it is, 10 to the power minus 7, which is given in the question. So the net H plus ion concentration, what is the net H plus ion concentration? Net H plus ion concentration is equal to the sum of these two, that is 10 to the power minus 7 plus 10 to the power minus 7, which will be equal to 2 into 10 to the power minus 7. So the pH calculation will be, pH will be equal to minus log 2 into, okay, minus log of net H plus ion concentration, which is equal to minus log of 2 into 10 to the power minus 7. That will be the pH. This is the important thing that you should note down. If you found out the acidity of an acid which is equal to 7 or greater than 7, which means you have to consider the concentration of H plus ion from water. At the same time, if you got the basicity of a base which is less than 7 or equal to 7, at that time you have to consider the concentration of OH minus ion from water. This is the point you should note down. Okay, is it clear everyone? Is it done? Shall I move to the next part? Yes. Okay, now the next is about the weak electrolyte. Strong electrolyte is over. Now for weak electrolyte. For weak electrolyte, what is the problem? What is the problem with weak electrolyte? Okay, Sangeeta is saying repeat once again. Okay, what I am saying is, for acid, if you got the pH value is equal to 7 or greater than 7, which means that is not correct. You are wrong, because acid can't be pH equal to 7 or greater than 7. In that case, you have to consider the H plus ion concentration from the water. And what is the H plus ion concentration of H plus in water? That is 10 to the power minus 7. Okay, and the concentration of H plus ion from the acid, this is from HCl, and the net H plus ion concentration only you have to substitute into the pH equation. Now for base also same. If for a base, if you got the pH value equal to 7 or less than 7, which means that's not the characteristics of a base, which means whatever the pH value you got, that is wrong. How you can correct it? You can correct it if you add the OH minus ion concentration from water. Concentration of OH minus ion at 25 degrees Celsius, concentration of OH minus ion will be 10 to the power minus 7. You have to add the concentration of OH minus ion into the pH equation. Okay, then only you have to find out the net OH minus ion concentration. Got it everyone? Is it clear? Is it clear, Sangeeta? Is it clear? Okay, now for weak electrolyte, I will be finishing it after telling the weak electrolyte. For weak electrolyte, let's suppose I am having an electrolyte HA. It's a weak electrolyte converted to H plus plus A minus. For weak electrolyte at time t equal to 0, let the concentration is C, this is 0, this is 0. And at time t equilibria, it will be C minus C alpha, because weak electrolyte won't completely dissociates into product. Only the alpha fraction or alpha amount of the C will be only converted to product, and that amount of reactant which is converted to product is C alpha. So at the time of equilibria, how much amount of HA will be there? That is C minus C alpha, which will be equal to C alpha. Okay, now what is H plus ion concentration? How to calculate the pH for a weak electrolyte? Minus log H plus ion concentration. And what is H plus ion? Minus log C alpha. Minus log C alpha. You can find out the pH. Now how to find out the C alpha? How to find out the C alpha? For that, find out the equilibrium constant, dissociation constant of acid, that is Ka, which is equal to concentration of H plus into concentration of A minus divided by HA divided by HA. Okay, on solving this, what you will be getting? Concentration of H plus, that is C alpha, A minus C alpha divided by HA, C minus C alpha. I can write as C into 1 minus alpha, Ka. On solving, Ka will be equal to C alpha square divided by 1 minus alpha. C alpha square divided by 1 minus alpha. Now the negation that you have to do here, what is the negation you have to do it? What is the negation you have to do is, for weak electrolyte, alpha value is far lesser than 1, so I can neglect. So 1 minus alpha will be equal to 1, I can neglect. So Ka will be equal to C alpha square. C alpha square. Okay, now from this how we can find out alpha? If you got alpha, you can substitute it and you can get the pH. Alpha will be equal to root of Ka by C. This is how we can find out alpha for a weak electrolyte. Got it? So these are the points. I want everyone to take a note of it. Yes, I think time is up. I will be finishing up these things up to here. Remaining things I have added it in the slides. What I want to say is, next is the pH calculation of salt. pH calculation of salt. How to calculate the pH of a salt? That everything, the equation only you have to remember. That everything I have mentioned in the slide. And the next is pH calculation of a buffer solution. Buffer solution, the definition of buffer solution is important. And then the equation for base and for acidic buffer. For basic buffer and acidic buffer, how to calculate the pH. That everything I have mentioned in the slide. Okay, so that are the important part. And the last one is solubility product. Solubility product, how we can find out the solubility product KSP, and how we can find out the solubility S, and how the common ion will be decreasing the solubility. These are the points I want to note, or I want everyone to take a note of it by yourself. Okay, this part I won't be taking because of the time limitation. It's a big chapter. Okay, if any doubt if you having, you will just reach out to me in WhatsApp or in by any way I can help you. Any doubt you can reach out to me. Okay, so that's all about today's class, students. So now all of you can go for lunch. We'll see you in the next class with the general organic chemistry chapter. Okay, tomorrow there will be exam. Okay, and the timing, everything will be mentioning in the group. You just be online with be in the WhatsApp and get the update of exams and all. Okay, so that's all about today's class. Thank you guys. Thanks for joining. We'll see you in the next class. Bye.